Hello and welcome. My name is Viral Desai. Today I have Jeff Anderson from Nationwide with me, and we are going to talk about Governed Data Lake built on AWS at Nationwide. I think you're going to hear a great story. I'm a principal solution architect with Amazon Web Services, and I help enterprises accelerate their journey to AWS. Jeff?
Thanks, Viral. I'm Jeff Anderson with the Data Architecture and Strategy team at Nationwide. For over 35 years, I've worked in a variety of software development IT architecture roles. These days, I support our Enterprise Data Office, uplifting our analytics and data science capabilities as product architect for the Governed Data Lake. Anyone with an S3 bucket and Athena tables has a data lake. But to maximize its power, the data must be findable, understandable, accessible, and coming from trustworthy sources. In the next 30 minutes, you'll learn how we delivered all of that and more with Data Lake as a service at Nationwide. A little bit about Nationwide. We started in 1926 as the Farm Bureau Mutual Auto Insurance Company. In 1955, with the aspiration of selling products from coast to coast, we became Nationwide. We're now one of the largest insurance and financial services companies in the world. We're still a mutual company, which means we answer to our policyholders, not Wall Street analysts and shareholders, which makes me really proud. I love working for our customers and our business partners. We've also been voted 8 times or selected 8 years in a row as the Computer World Best Places to Work in IT. So as an IT guy, that makes me really happy because it is a great place to work. We obviously work in a highly regulated environment, being an insurance and financial company, so we do have some unique challenges to deal with when it comes to building a data lake. So when you've been in business for almost a century, you tend to collect a lot of stuff. We have thousands of databases that are being fed each and every day by hundreds of thousands of ETL jobs running everywhere using all kinds of tools. We even have ETL written in assembly language running on our mainframe. Talk about some technical debt. All of that's feeding into a lot of proprietary data platforms. If you've heard of them, we probably have them. Our data center is full of big, expensive warehouses and marts and other types of data repositories. The problem that we don't really have an economical way to store data except for in our warehouses and marts. So a recent internal study found that 80% of our data that we're storing in these big, expensive platforms is not even being accessed. So we'd really like to have a way where we can store that without having to put it in these expensive platforms. The other thing that's happening is our business is changing. We get a lot of forms that are sent in PDF form for our sales and service center. Our claims associates are submitting lots of photos and videos. And of course, we have a lot of IoT data from smart home and our smart miles devices. All of that we need a place to store that economically. Viral, I know you've had a lot of AWS customers with similar challenges. What types of solutions have you talked to them about?
Yes, Jeff. I see these challenges all the time within enterprises. There are many different personas or internal customers within enterprise that interact with the data. For example, data scientists like to build predictive models and algorithms. But before they can do that, you have to source this data from multiple different sources. You have to collect them, cleanse it, and also convert to specific format. And data engineers are critical to that. Data analysts look at the quality of the data and ensure that the data represents the real-world scenario. You have information workers and decision makers who look at the data reports and ad hoc analysis and dashboards to make decisions that leads to better outcome for your customer. This entire process requires end-to-end administration of multiple different sources, purpose-built engines, things like retention, encryption, and access controls are very important. As you can see, there are many different personas that have unique needs and challenges when they work with data, but these challenges are interrelated. Enterprises know that data is the new oil and it's very valuable. So in order to solve some of these challenges, enterprises build data lake. A data lake is a centralized repository that allows you to store structured and unstructured data securely at any scale. You store the data as is without having to convert to a specific format. And once you store that, you can run different analytics, big data processing, machine learning. You can use the same data to create dashboards and ad hoc reports. Let's take a look at how some of the customers have used data lake in past. For example, you can centralize all your customer call volumes or customer interaction with your product and services and centralize this data. Once you have that data centralized, you can run analytics to understand how to build new features that really affect the customer outcome. You can also take industry and market analysis and trend data and centralize this data into data lake. Using this data, you can create some innovative products. You can also use this data to create machine learning and predictive algorithms and models. This leads to automation in some of the manual processes, which leads to better outcome for your customers. As you can see, having a centralized data lake strategy not only allows you to democratize the data, which leads to greater use of the data within enterprise, but it leads to better outcome for your customer and which adds value to your business.
Yeah, Vero, 100%. We needed a data lake for sure. Since we started AWS more recently, when Hadoop was the big thing and the total coolness, we decided we want to be one of the cool kids. So probably about 8 or 9 years ago, we started building our own data lake using Hadoop and ran that in our data center. It came with a lot of the benefits that you mentioned, but also a lot of challenges. Anytime you're managing your own infrastructure, there's tons of server patching. That leads to frequent downtime for maintenance. We also ran into some really crazy stuff. Like we needed to upgrade to the next version of Hadoop, but our ETL software had a bug that didn't work with that version. So we had to wait on the vendor to fix the bug so we could upgrade. That cost us a lot of time in our schedule, and it really was a total downer. Another thing, Hadoop is great for using commodity drives. The problem is you got to put those drives in a server. So if you need more storage, you're typically having to order both commodity drives and servers. And even with all the contracts in place, it takes a long time to go from a new server order to having a new node in your cluster. All of those servers and all that software comes with a large upfront capital expense and a lot of fat maintenance contracts for the vendors. Because it was so expensive, we had to create this big shared environment. The challenge with that is you have a lot of business users conflicting with each other. They're running jobs, everybody's got quarter-end processing, and they're all trying to get in there and get their work done. So it creates a little bit of chaos having the entire company trying to use the same shared environment. It also makes it kind of hard to secure. So when you have an organization with 30,000 associates, any kind of big shared environment is probably the most complicated to secure. So one of the questions I get a lot is, what is a governed data lake? I think Viral did a great job talking about what is a data lake and what is the value propositions, but what does it mean to be governed? When we were thinking about how do we move our Hadoop data lake into AWS and use the cloud native technologies, one of the design constraints we had was each business unit has their own set of AWS accounts. So we needed to deploy the software to every account, and we wanted to make sure it was centrally managed. We didn't want each business unit running off and creating inconsistent software, having different types of, different approaches to building the data lake. We needed a central service for that. The conversations we were having really was, how do we do that, and what's the key things we need to keep in mind? In a conversation with my boss, our chief data architect, the conversation that really struck me was when he was talking about how the data lake must be governed. It's nationwide data, and it must be findable, understandable, accessible, and properly classified so we can secure it. When he was talking about that, really resonated with me, and that was sort of the aha moment that created the governed data lake. So we distilled it into 4 key points. Just as he was talking about, the data must be profiled, analyzed, and classified before it can be added. This goes a long way to getting rid of that data swamp. You have users that are looking at the data quality. We understand who owns it and where it came from, and things like that. So having that little bit of work up front to identify what is the data and where it's coming from and what its quality goes a long way at getting, avoiding the data swamp problem. Data must be understandable. If you have data and you can access it, but you don't know what it means or what the characteristics of it are, it doesn't do you a whole lot of good. So we needed to capture that business and technical metadata and make sure that we got that recorded somewhere so that as people were using the data, they really were able to use it for the right business purposes. Data lineage is really important, whether you work in a regulated company or not. With regulations like California privacy, we need to know where the data is coming from and who's using it, just for regulatory reasons. But another reason why lineage is important, data quality. If it's my copy of Viral's data that he got off Susie, who got it off of Joe, you kind of wonder what's happened during all of those hops as people added it at their transformations that we don't want. So understanding that it came from the system of record versus Viral versus Susie versus Sally, those are things that sort of help you understand, should I be making business critical decisions off of this data or not? So lineage is key to that. I think finally, data must be discoverable and accessible. Most of our great business innovations come from the people in the field processing claims, meeting with our, people that are doing our retirement plans, or even our call center representatives. Those are the ones that have the aha moments and think, boy, I could really automate this process, or here's a new product idea that we have, if only I had the data to do that. So we want to make sure that the data is accessible to everybody in the company in a safe and secure way. Our CEO was talking about how data is the lifeblood of the company, and the more that we can give all associates access to our non-sensitive data, the better. Fortunately, we have a solution for data findability. The Nationwide Data Marketplace, which was inspired by data.gov and built on the same open data portal technology called CCAN, is our data marketplace. It's our data catalog of data catalogs. And that's really important, whether you're an organization that's big or small. Once you start getting more than a handful of data sets, you need to be able to catalog them so you just don't lose track of them and you know what you have. Being API driven, it also made it easy for us to integrate our software with CCAN. So the real thing that we wanted to bring to the table was we wanted to catalog the data so the data providers didn't have to. Another thing is data understandability. So the Nationwide Governance Catalog really is what solves that for us. It's an existing product that we are using internally at Nationwide, and it combines a business glossary with a metadata repository, and it's built on the Enterprise Data Intelligence product from ASG Technologies. The data marketplace allows people to find it and sort of understand the high-level information about it, whereas NGC allows you to really drill into the details. It's the primary keys, it's the field layouts, all of those technical details that really allow you to drill in and get a deep understanding of your data. It's also API driven, so integrating with it is a breeze. So some of the other things that we wanted out of our data lake, besides those two particular governance items, was having it be configurable and fully automated. We wanted it to be event driven, no need for schedulers or third-party software, just drop files and go. We wanted low cost, and fortunately S3 is a great low-cost place to store all of our data. Whether you're regulated or not, having a secure and auditable environment is really important to protecting your customers' data. And I think any time that you're getting charged by byte scanned or working in an analytic platform where you're typically dealing with thousands or millions or billions of rows, having a data set that's optimized for query consumption is really important. Some of the toughest conversations I have are with the business units that really expect millisecond response times out of analytic queries, and helping them understand that we need to shape the data in ways that facilitate that is incredibly important. Also, with being charged by byte scan, by offering a service where we automate that conversion into a query optimized format, that saves us money and it gives us the better performance that our customers really want. The other thing that I want as a sort of a product architect is minimal support. I truthfully don't want to have a support team. We don't want to be on call or do anything 24/7. So that was my requirement to the developers is, hey, let's figure out how to make this so we don't have to support it day and night. Of course, I got a laugh. Everybody laughs when I say self-supported, but truthfully, As long as you make the stuff fault tolerant and all the automation that's available with the AWS services, it's actually not too hard to get that goal achieved, and we're well on our way to doing that. Finally, we wanted stuff to be self-service. No need to fill out tickets to get stuff from the data lake. Just drop your files and go. So let's talk a little bit about the architecture. Viral, you and I spent a lot of time in conference rooms trying to figure out how we could build this stuff with all these different requirements.
Yeah, Jeff, this slide is going to be a little bit busy, so let's talk about what we are showing here. So you have on the top left is AWS account for a given business unit. As you can imagine, Nationwide has many business units and they all have their own AWS account. What we are showing you here is one account for one business unit. You have a centralized team that actually takes a code that is reusable code and that gets deployed into different business unit account. I think one of the first things that Jeff, you and I, when we were talking in the early days, whether to centralize the data in one account for data lake or keep them separate, I think we made a decision based on some of the criteria like security, how do we maintain the ownership and let business unit still own the data, not making duplicate copies of it. And that I think led us, and also the chargeback. I think the chargeback was simplified when we kept the data into each business unit's account. So I think in the hindsight, with some of the new features that we just have announced, I think it makes it really easy now to leave the data where it is.
Yeah, and I'll tell you what, you wouldn't have a data lake without Amazon S3 for your storage. The cool part about it is once you drop files in there, it kicks off events. That gives us the event-driven processing that we were looking for. The self-service part comes in terms of the configuration file. So you'll notice we have a data file and a configuration file. That configuration file has information like who is providing this data, what is the data sensitivity, everything we need in order to be able to properly classify it and secure it and do catalog operations. Once the user provides the configuration file, it registers it within the data lake, and from that point forward, they can start dropping files. So that's once the configuration completes, they can drop data into it, and dropping that into S3 kicks off that processing using that S3 event.
Yeah, Jeff, I think that's super important. Here we introduce Amazon SQS, the queuing service, to separate our ingestion layer of the architecture with the processing layer. This is primarily done to make sure that we can protect the processing layer from a surge that can happen on the ingestion layer, and also not to lose any files or data that we can receive from S3. So I think this is an important design consideration here.
So we also had an interesting opportunity to reuse some existing software. Our data integration framework was some software that we built to facilitate ETL. It's an accelerator that allows us to acquire and transform and load data into various data platforms. By reusing that, we were able to get a jump start on the data lake automation without having to start from scratch. It runs in Kubernetes, and one of the great things with SQS, we were able to look at the queue depth and do some auto scaling in Kubernetes, so we could really use that elasticity that you love about the cloud to scale up and down the processing in Kubernetes.
Yeah, and I think the next thing that happens from there is like if the configuration file that you mentioned has instruction about optimizing the file format by converting into Parquet, then there's a task in that orchestration flow that allows you to convert it and store it in an optimized bucket. And it can also send an event to Amazon SNS topic so that any users of the data or subscribers who are interested in that process of that file or processing of that file would get notified through SNS.
So a few other things that the software does. First, we wanted to do the catalog operations for the user. So when a data provider gives us that configuration file, we create the databases and tables. As they add new data, we do the partition management for them. So that's a great service, and automating that helps them out a lot. Secondly, we're also taking advantage of cross-account sharing, which is a reasonably new feature that's come out of lake formation. When a user wants to share data with a user's another account, they put that in the configuration file. The automation software, when it sees that, will stick events into a second SQS queue so that the configuration can be completed in the account that's receiving the sharing. We also do lake formation grants to make sure that we're getting least privilege access to our sensitive data. And as I mentioned, there's a second set of Kubernetes pods that will pull the events out of that second cross-account sharing queue and make those local catalog entries. Finally, we want to make sure everything is auditable and tracked. So we're using Amazon Aurora and storing events in a database there so that we can create dashboards and really show off how much use the data lake is getting and provide management with various statistics. And also, it's a great way to have an audit trail. And it's the governed data lake. So part of that is all of the cataloging and everything where we're integrating with the data marketplace and soon to be the nationwide governance catalog. So that is also part of our processing.
Yeah, so I think once the data is cataloged in lake formation and also nationwide governance catalog, it allows business unit users to use services like Amazon Athena to do some queries against local data or the data that was shared via cross-account lake formation feature. So this makes it easy to manage the access to a specific catalog and tables and data itself.
So building the data lake's been a lot of fun, but once you have a data lake, part one, the next problem is making sure people are using it. At Nationwide, like I said, we have a ton of ETL. I mean, we're just blessed with ETL. One of the common patterns we have is our source system will provide an extract. That extract goes on what we call a landing zone, and that's just a fancy name for network attached storage on a server. From there, a second set of ETL jobs pick up that data and send it to wherever it's going, whatever, data warehouse or MART or other repository. By simply replacing that landing zone with the governed data lake, we were able to integrate the data lake with our existing ETL with a minimum amount of changing. An added benefit of this is it creates a queryable archive of raw data. This is incredibly powerful because we no longer need to load everything into our most expensive platforms. We simply load what we need, and then if we find we need more data later, we can source it from the governed data lake, complete with history. This allows us to reduce storage costs in our expensive platforms and also simplify and in many cases even eliminate ETL. So one of the things I love, and I would call myself, I guess, the data lake pappy or whatever, because this has been sort of a pet project for over a year. And it's fun to see our business units taking what we built and put it to great use. So, for example, our Nationwide Financial Services Group is ingesting Salesforce data and combining that with some of their administrative system data to create more effective marketing campaigns for our financial advisors. Our specialty insurance unit is using raw data sourced from a variety of administrative systems to build and train machine learning models to improve the speed and accuracy of our insurance underwriting. Another example of how the data lake is being used is our auto insurance team is using it to store trip data from members enrolled in our Smart Miles program. They're using it to create personalized tips to help members maximize their safe driving discounts. These are just a few examples of how the governed data lake is helping Nationwide deliver on our mission to protect people, businesses, and futures with extraordinary care. Viral, we spent a lot of time building this, and we learned a lot of things along the way. I think for me, probably one of the key set of lessons came from an experience we had. We built this thing expecting more of a batch flow mentality. We were expecting our administrative systems to deliver files probably at most daily. And what we really found out is even though an MVP where you're targeting the big nuggets and working towards sort of adding that iterative functionality later, you got to be cognizant about how people are going to use it in ways that you don't expect. And one of those things was when we had a user try to add streaming data into the data lake. We built it sort of expecting that we would get large files and we would be able to convert them to Parquet efficiently. And what we found is with streaming data, there's lots of little files that don't perform well in a data lake. So it's very important with any data lake that you have larger, sort of a smaller number of large files. That works really well, whereas a whole lot of small files, that doesn't work so well.
Yeah, Jeff, I think that specific use case taught us many other lessons, and the next one is right in line with the first one. One of the things that we learn when you are doing the optimization is that when you have large batch files, it really works well converting to Parquet. And we were using Athena's feature to convert to Parquet. Now, Athena is a great querying tool, and you are able to run many queries, but when we started getting lots of small files, 100 bytes, it didn't make really sense to convert them to Parquet or even use Athena for conversion because the number of jobs that would run were very large. So we ended up either completely not optimizing it, or we moved that whole conversion to Parquet into our compute layer.
Absolutely, it's important to be thinking about these kind of things. And truthfully, scale is probably the big thing that I learned also. Our data integration framework was a great way to get started and not have to build everything from scratch. The challenge is it's kind of a long sequential program. It runs several steps, just one after the next in one thread. By breaking that up and allowing each thread to operate independently and be able to multitask it as much as possible, it really went a long way in improving the scalability of our architecture.
Yeah, and I think that's a great point because as we discussed earlier, we introduced queues in multiple different places in the architecture to add loose coupling, and that allowed us to scale each component independent of the other component. Also, it helped with some of the error processing where we were able to handle the errors better and not lose any file or event, and the whole retry logic, etc. So I think that was another great lesson that we learned.
So another lesson I learned is partner with the AWS team. You guys have been great partners, and our new design is so much better. We benefited from your experience, and I know we've avoided a lot of technical debt along the way.
Thanks, Jeff. I think that partnership works both ways. In partnering with customers like Nationwide and you and your team, we have learned what the real customers actually need when they start building out such complex architecture. So some of the inputs that you provided in the early stages were very influential in some of the product roadmap, things like cross-account lake formation and also AD Athena. Those are some of the really good inputs that your team provided.
Yeah, absolutely. Those two in particular were definitely items that are high on my list, and it really went a long way in helping us create a collaborative platform, a secure collaborative platform to spur innovation at Nationwide. There's a few things in our roadmap that really align to that central theme. First, cross-account sharing we've already implemented. The next thing that we want to get in is Active Directory integration, and that's only been recently released. But our users are really excited that they're going to be able to use their Active Directory credentials to run queries in Athena. So they're going to be super happy when we finally get that out the door. Secondly, our data providers in many cases are giving us classification down to the column level. We want to add additional automation and use some of the features in lake formation to create a non-sensitive view of some of our sensitive data sets. In doing that, we can go even further at making more data available to our associates to hopefully have them be able to think about the next great innovation for Nationwide. Another thing that we want to do is, if I go to the data marketplace now, I can see who owns the data set and who I need to go get permission from to have access. But it's all manual. I have to email them, call them, maybe even send them a postcard asking for access. We want to automate that. By adding a request access button directly onto the page, it's going to kick off an automated workflow. Once everybody's approved it, we're going to use the AWS Glue APIs to be able to go in and do those table grants to allow the requester access immediately. And then once they're done with the data set, we'll be able to revoke that access automatically. So we're really excited about that capability as well. Finally, our data providers are really good at classifying data, but occasionally stuff slips through the cracks. We're wanting to use Macy to scan our S3 buckets and create automation that will automatically lock down misclassified data that Macy finds when it's scanning.
Yeah, Jeff, I think those are really good ones. And I think the other few items that we have seen is like, I know we have been talking about the whole streaming use case and adding support for streaming in a way where data provider doesn't have to think about file sizes or frequency and just do the configuration and forget about it and let data lake process those streams is a great addition. I think we are going to work on that. The other one is the slowly changing dimension. You know, if you have data that has those type of characteristic, then I think we are planning on working on with our ProServe team to add Apache Hudi support into this architecture also. And then finally, we want to complete the integration with nationwide governance catalog APIs so that as the data flows into the data lake, we make those APIs call and get that data visible in your governance catalog. I think that would be a great addition too. So I think that brings us to the conclusion of this session. I hope you all enjoyed it. Thank you very much, and thanks, Jeff.
Viral, thanks for your partnership. It's been a great journey to build the governed data lake at Nationwide, and thanks for watching our session.